Okay, so today we're going to have a look at the first 5 questions from the geometrics proofs exercise. So, question number 2 says that in triangle ABC, point D is shown on AB, where AD to DB is 1 to 3. So AB to DB is 1 to 3. We're going to write that ratio on our diagram. Given that AD is A, so AD is A, and CB, AC is B, AC is B, and CB is C. Show that C plus B is 4A. Okay. Well, a couple of things we might want to consider here. So B plus C. So here we've got B, and we're adding C. It might be important to note that AC plus CB is equal to the vector AB. So AC plus CB is equal to the vector AB. So AC we know is B, and CB we know is C. So that gets our A plus C, and that's equal to vector AB. Let's figure out what vector AB is. Well, if vector AD is 1 and vector AB is 3, because they exist in the ratio 1 to 3, then vector AB would be 4 lots of AD. Because the whole ratio, there's 4 parts in that whole ratio. So vector AB is 4 lots of A. So therefore, AB is 4A, and we've proven it. Done. Okay, question number 3. We've got in the regular octagon A, B, C, D, E, F, G, H, show that AD is HE. So AD is HE. Well, if we look at this octagon, AD is going to equal AB plus BC plus CD. And at the same time, HE is going to equal HG plus GF plus FE. However, AB is equal to HG, BC is equal to GF, and CD is equal to FE. And in fact, all of those are equal to each other. So AB is equal to HC, which is equal to BC, which is equal to GF, and so on. And that's because the shape is an octagon. And an octagon has 8 equal sides. So therefore, AD equals HE. Okay, question number 4. We've got in the trapezium ABCD, AB is parallel to DC, okay? And P and Q are the midpoints of AB and DC. Prove that AD plus BC is 2PQ. Okay. So we've got AD plus BC is 2PQ. So what we might do here is we might call AB vector A and DC vector B. And actually what I might do is I might screenshot this and just move this diagram down to here. That's a bit bigger. And we have to prove that AD plus BC is 2PQ. Okay, we might want to state a few things. I might call AB vector A and DC vector B. And then what I might do is I might say that PQ, well, PQ is equal to AP plus AD plus DQ. And I might say at the same time PQ is also equal to PB plus BC plus CQ. Okay, so that's two statements there. So they both are PQ. What I might do from here is realize that AP and PB, AP, actually, we're going PQ. I think that should be PA. So yeah, PQ is PA plus AD plus DQ. And PB, or PQ is also PB plus DC plus CQ. Now PA and PB are actually almost the same vector. So PA is equal to minus PB. So PA, well, since it's a midpoint, then that and that are the same length. So PA is minus PB because they're going in opposite directions. So let's say this is minus PA. Plus, if we have a look at BC, that's BC there, plus CQ, well, that's CQ there, and that's actually going to equal minus DQ. So we might say minus DQ. Okay. So now I've got one expression for PQ here and another expression for PQ here. So that one is this one I'm writing down now. So PA plus AD plus DQ. Now if I call this equation 1 and this equation 2 and I add them, I get 2PQ equals, the PA's die, AD plus BC, and the DQ's die. So we've proven the identity that was required. Amazing. And the last one, I might screenshot this and move it down again. So I've got in the diagram 2BC is equal to 3CD. So 2BC, so we might put a 2 here, and so 2BC is equal to 3CD. So we've got 2BC is equal to 3CD, so we might write that down. 2BC is equal to 3CD. Now that means that the ratio of BC to CD is equal to 3 over 2. So BC to CD is 3 to 2. So BC we're going to call 3 and CD we're going to call 2. And it's given that BA is equal to A and BC is equal to B. BC is B. I might put that up here actually. And we're going to show that AD is equal to 5 on 3B minus A. Well, let's think, okay, AD, first up forgetting about those vectors A and B, AD is going to be AB plus BD. Now, AB is starting from A and going to B, and that's the opposite direction of A, so it's going to be minus A. Now, we know first up, we know that, so we're going to add BD. So we're trying to figure out what on earth BD is. So we know that BC is equal to, we know that 2BC is equal to 3CD. So that means that BC is equal to 3 on 2 CD. And we want to find, and we also know that, so BC is 3 on 2 CD, and we also know that BD is equal to BC plus CD. So BD is BC plus CD. So BC, we've said, is 3 on 2 CD plus CD. Now 3 on 2 plus 1 is 5 on 2. So 3 on 2 plus 1 is 5 on 2 CD. So BD is 5 on 2 CD. We also know that, let's have a think. So we know that 2BC is equal to 3CD. So that would mean CD is equal to 2 on 3 BC. So 5 on 2 times by CD, which is 2 on 3 BC, which is 10 on 6, which is 5 on 3 BC. So BD is 5 on 3 BC. And 5 on 3, well, BC is equal to the vector B. So BD is 5 on 3B. I think there would have been a much quicker way of getting that, but I got there eventually. So BD is 5 on 3B. So back up to here, AD is minus A plus 5 on 3 B, which is what we were trying to prove. 5 on 3 B minus A. Did we have time for one more? Actually, I might leave the rest of those for you to do for you guys to do on your own. So we've got AD is 5 on 3B minus A. QED. All right, thank you.